Hi, my name's John. Welcome to another Sunday night nightcap. As you can see, we're looking at a different end of the shop. Tonight I've moved things around a bit, as I'll show later on. Tonight's nightcap is nearly all about crankshafts for this little vertical steam engine. Do quite a lot of machining, some fabrication work, starting to make up the crankshaft. Yesterday I was at Doncaster with Mick and Bob and David at the Model Engineering exhibition. I put a little bit of video of that in towards the end. It was a good day. It wasn't as busy as it was last year, but it was still well worth going. I bought one or two little bits and pieces, mainly some tips and some screws for me tool holders. What was not interesting, it was actually quite humbling, was the amount of people that actually come to say hello and shake my hand. It was absolutely fantastic to meet so many of my viewers. So if you did come and say hello, thanks very much. I'm not quite sure what to say, but it really was nice anyway, and everybody had nice things to say about us, so I suppose I must be doing something right. Mick called down today with Stig, and we actually got Stig to pull a name out of the bucket for this week's giveaway, which is that lovely little DTI. What's in there? Good boy. First time. Good lad. Sit. Good boy.
Stephen Bennett. Stephen Bennett.
Good lad. Hey. Cool. Anyway, Stig, thanks very much for that. I'll make sure I get that in the post this week. I received a package at work this week from a lad called Richard, containing quite a few milling cutters. There was actually 4 brand new 20mm milling cutters, quite a few 16s in some nice metric taps. I'm going to make a little package up for this week's giveaway. It's going to be a 20mm milling cutter, brand spanking new, a 16 milling cutter, and this nice little homemade depth gauge. I'll get a close-up shot of these a little bit later on. If you want to go into the draw, participate in the draw, all you have to do is send me an email. That's my email address up there, with your name in it. If your name's pulled out of the bucket, I'll post it off to you anywhere in the world, completely free of charge. It's just a little way of me giving things back. I mean, I've already got 2 20mm milling cutters. I don't need another 4. I'm never ever going to break or wear out all their milling cutters. So instead of them just lying in a drawer, he's given them to me to do with whatever I want, and I would really like to give them away to somebody who's going to make use of them. If you win the milling cutters and you haven't got a milling machine, give them to somebody that has. These are the milling cutters and the taps that I got this week. Like I say, most of them will be given away. There is some that I haven't got, I'll be keeping. That depth gauge is quite a handy tool. I have used it myself on several occasions. It's obviously homemade, quite nicely made. And that 20mm cutter's brand new, and the 16's been resharpened and it's in good condition as well. The material for the crankshaft turned up today at work. This is 1-inch diameter silver steel, 13 inches long. Some nice imperial sizes for you. Interesting why they make it 13 inches, but that's what they do. I was talking about having shrink fit and weld. Obviously I can't weld silver steel because it's high carbon steel. It'll crack, it'll go hard. So what I'm going to do is have shrink fits, because shrink fits are really strong. Shrink fit and cross pin. So a shrink fit and pin is the way I'm going to go. I found a bit of material here that I can use for the crank webs. All I'm going to do is give it a rub with a file, make sure it's flat. I'll cut this in half, weld it together, tack weld it together, and machine both halves in one go, or at least machine the 2 centres for the main bearing and the crank pin when they're welded together. The engine's going to have a 3¼ inch stroke. which gives a through of 1 5/8, which is basically what that is there. That's going to be the crank line in there. When you get, they'll probably be either line bored or reamed out to inch. Obviously the conrod goes in the centre, so I'm limited at how much I can have each side. For the cheek pieces on the crank, that's actually too thick, but it means when this is shrunk fit and pinned onto the shaft, I'll be able to machine the faces up. This is going to be the front of the engine. That's the port face called the front. The back is where the flywheel goes. On the front bearing, we've got caps on. Bearing goes on there like that. And as the bearing cap goes on with an oil hole, so that oils our main bearing. So on the front one, I'm going to drill the crank, drill through there, drill along, drill through the web, so that it feeds oil into the big end bearing, just on the front one. And the back one, which is the one basically with all the load on with the flywheel, that'll be left just feeding the bearing. I don't know what design. I've seen some of them have oil caps and things on the big ends ourselves, but I've also seen them with a crank drilled to carry oil to the big end. It also means where I put the drilling through the crank web, I can also use that hole to pin the crank together. But I reckon I can get away with a 4th thou interference fit, 4th thou shrink fit, which is really tight, and then drill it and probably Loctite pins in. I've thought about turning the crank out of the solid. I may do that at some later date, but for the minute I want to do a built up crank. This bit of steel looks flat and nice, but it'll have dints and bumps in it. So I'm just going to run a file across it, draw file, draw the file across. You can see it's really only touching the two outer edges. I just want to make sure that it's flat, so when I weld it together, or tack weld it together prior to machining. Okay, that's better. So now cut it in half, tack weld the two together. Right, as you can see, it's been cut in half. I've laid it flat on a surface plate, clamped it together. I'll probably put 2 tacks on each side, square the ends up in the milling machine, and then I'll probably use a mill to mark out accurately the 2 centre holes for the crank through, put it in the lathe, drill ball, ream them to 7/8, still all welded together, and then that means that the 2 holes have got to be in the same place on each part. I'm just going to put some tack welds on with a TIG welder. I won't need any filler wire, just fuse it together. I've just realised what I've done. I've actually welded that up without any gloves on, and I should really be consigned to hell and back for it. Not good practice. Right, so basically now they're nicely tacked together, just little neat tacks, that's all it needs. All I'm doing is machining the ends of the 2 blocks square. As you can see, I've got it held in the vise up on 2 parallels, so it's only gripping on the bottom piece of material, and it's just the tack welds that's holding the top one. Putting the feed on this way, this is conventional milling, we're going into the direction of rotation. If we're to put a feed on going the other way, I Let's just say going that way, that would be klein milling. Not really a good idea on a small lightweight machine like this. Right, that's reasonable. I found it's nearly as quick just to leave that on all the time and use it like a drill chuck. It's certainly more accurate. What we need to do now is find the exact centre of these two pieces. So I'm going to use an edge finder to find the edge. One edge, other edge, split the difference, and that'll give us the middle. Take it in until it stops moving. And then it kicks off, zero the axis, we'll do it again. Right, once more, just going to get the feel of it. That's it there. So that repeated itself, zero both times. Cross to the other side. Same thing. Got a reading of 58.9. I'll do it again. .9, once more. .9. So we'll call it 58.9. Right, we've got 58.93. So about half that's 30. Well, half's not 30, but 30 would certainly be accurate enough because they're both going to be drilled in the same place. And take it up to 30. That will do it right. Right, so it'll be 29.96 if you want to split hairs. 29.9. 29.9.96, which is 400ths of a mil off 30. Anyway, that's the middle. We'll lock the y-axis off at that. Right, this is going to be the location for the big end pin. I made it 1 inch from the end, so when the inch hole's drilled, it'll have a ½ inch meat left on the end of it. I'm going to have to decide if I do this in metric or imperial. You can't really do it in both. Anyway, I've zeroed the x-axis, so I can centre drill this one, then move it across the distance that's going to be the stroke. Come on, bastard thing. Right, a little bit of cutting oil. Right, that's the first one. So now we need to move this. I worked out we're going to have a 3 1/4 inch stroke. So what I'm going to do is make it 3.2 inches. Which means the distance from there to that one needs to be 1.6. Which will give us a stroke of 3.2. right, 1.6. It never does any harm at all to get a ruler and just verify it, and that is 1.6. Right, so we've got 2 lathe centres here, which I can easily pick up in the lathe and the 4-jaw chuck, and that'll be tomorrow night's job. Drill, bore and rename 78s. I need to drill and ream these 2 holes out to 78s. I'm going to set it up in the 4-jaw chuck to do that. I'll do the centre one first. Well, it's not actually the centre, but it's the nearest to centre first. What I'm going to do is bring in the lathe tailstock with a centre in it and use the centre to hold that roughly in place. See, I've got aluminium jaw protectors. Well, they're not jaw protectors because you don't protect the jaws. Aluminium packing pieces in there so I don't damage the workpiece. I'm going to do the same with these 2. Just get 2 little strips of soft aluminium. These cutters have certainly seen better days. I've had them a hell of a long time. Right, so we'll put a piece in there. And a piece in there. Right, if this was going to be a bracket for a fence, that would be near enough the middle. But being as well it's going to be a web for a crankshaft, it's going to be absolutely spot on in the middle. So what I'll do, I'll put a centre in there with a clock gauge on it, and I'll clock it in so it's running absolutely true. You can use it, I've got spring loaded centre finders, but I find this one works as good as anything. You can see it is running out. It's not running out much, but it's running out. I've got various types of indicator holder, and honestly I find this the best thing to use in the lathe. It's just, I suppose, what you get used to. Right, it hasn't actually got a high point, it's jumping half a thou all over the place, so it's basically running through that way. I'll put the clock on again the other way. See, the closer in you have the clock to the hole, the more accurate you're going to get. So we can move this right in now. And put it on there. Right, we're getting a bit of movement now. Right, it's got full 2000s, so we find the high point, which is there. tighten up the high jaw. Right, we've got that down to half a thou now. Once again, high point, which is there. High point. It's getting good now. We're sort of within a quarter of a thousandth there. We've made it worse. High point. Just knowing when to stop, and we're getting near the point now we're going to stop. Right, that's pretty good there. A couple of tenths of that. Less than half a thou, so I'll settle for that. Way less than half a thou.